we're in the process right now of rebuilding the Goldie's headstock, and as those of you who saw the last installment of this, there was some pretty extensive damage that had to be repaired. Now, there is no way for me to know what damage you may find in used machines that you buy. So what we're going to do over the next 3 or 4 sawdust sessions is I'm going to walk you through every possible major repair that you need to do on the headstock. And today we're going to concentrate on the back end of the headstock, because this is usually where most of the problems crop up. I've got our cutaway here instead of the Goldie. Believe me, if I was showing you how to do this on the Goldie, you could see nothing. All you would see me with a hand stuck in the machine half the time, and me telling you what I'm doing on the inside. This way, at least you'll be able to see what's going on. This is a B headstock like the Goldie. We had Shopsmith has manufactured 3 types of headstocks over the years. From 1953 to early in 1955, Magna Engineering, which was making the Shopsmiths then, did a sandcast headstock. After that, they figured they had a winner on their hands with the Mark V, so they invested in the dies and the molds, and we have a die-cast headstock. In 1991, we made some improvements on that mold, enlarged the hole in the side so you could get your hand in and out easier, and made a few other changes, and that was the C headstock. Now, all the functions that I'm going to be performing today are the same, whether you have an A, a B, or a C headstock. So, we're going to take a look at the drivetrain and what might be wrong with it, going from the drive belt, the motor sheaves. Those of you who aren't familiar with the guts of your headstock, the Shopsmith has 2 sets of sheaves that expand and contract, and this in effect are variable pulleys. As one set of sheaves gets closer together, the other set of sheaves gets farther apart, and this changes the pulley ratio between the motor and what we call the idler shaft right here. I'll be showing you this in a minute. And we have a drive belt which runs between the motor sheaves and the idler sheaves. This is what delivers the power to the motor. And then we have either a poly V belt or a Gilmer belt between the idler shaft and the drive shaft itself. The poly V belt is a lot of it's a grooved belt. The Gilmer belt is a stepped belt. We went to the poly V belt. The older machines had the Gilmer belt because the poly V offers you some important safety feature. If you have a catastrophic stop, and by that I mean something like a block of wood falling into the lower saw guard and causing the machine to stop right away, the Gilmer belt would halt everything right there. And the catastrophic shock can be very hard on the internal parts of any machine. Think what happens to your lawnmower when you hit a rock, for instance. With the Gilmer belt, it stopped. There was a hard stop all the way down the line. With the poly V belt, there's a slight amount of slipping, and everything comes to a much softer spot, and there's much less likely that that a catastrophic stop will create damage. So if you have an older machine with a Gilmer belt and something goes wrong with either the idler shaft or the drive shaft, you might think about replacing that Gilmer belt with a poly V. All right, what I'm going to do is I'm going to tear down and then build back up the entire drive system, explaining what I'm doing as I'm going. So we're starting now with the machine plugged in, and I'm going to run it up to high speed. already there. Okay, now let's unplug the machine. This is very important. You really don't want to have this thing start while your hands are in there. Now the next thing we're going to do is we're going to take the drive belt off. I'm going to go over here and get a 3-inch faceplate. And I'm going to put that faceplate on the drive spindle so I have something to hold on and turn the drive spindle when I need to do so. That makes a nice handle. You'll notice that in the service manual, I put pages 1 through 12 of the official Shopsmith service manual. It says use the sanding disc. That'll work too. I just like this because it fits my hand nicely. I really don't have that Jordan spread on my fingers to grab a sanding disc. Okay, I'm going to take the belt and pull it hard towards the back of the machine as I'm turning, and there we go. The belt just slips off the lower set of sheaves. Now, I have this is the control sheave. By the way, all 4 sheaves have separate names. This is the control sheave, the idler sheave. The sheave closest to the motor is the fan sheave. It keeps air moving through the motor so that no sawdust builds up in there. And then this on the outside of the motor is the floating sheave. And if you'll see this, I can pull this, and it actually floats back and forth automatically. The spring here on the drive shaft is what maintains the tension on the whole drive belt system. Okay. Now, if we come in close here, and I'm going to tilt this up a little bit so you can see just a bit better. There is a quadrant here, and we call it the pork chop. This is the thing on the back of your speed changer which moves the control sheave in and out, and it's held to this quadrant by a little wire loop and a spring. I'm going to depress that spring. There's the spring right there. Okay, and I'm going to take the loop off. Now, at this point, my control sheave is free floating. It'll go back and forth like this, so I can work the belt out from around it, around the pork chop, and out like that. Drive belt out. So if you're replacing a drive belt, you see it's really a pretty simple operation. But let's go on. Let's say that there's something wrong with the idler shaft. So getting the idler shaft out, we need a 1/4 inch Allen wrench. We're going to loosen and remove completely this bolt. Now as you do so, and there's the first thing that I've dropped today, a washer. Okay. This is a lock washer. As you remove that, check for any cracks around these 2 little ears. A lot of people who don't understand the Mark V system over tighten that bolt that I just removed, and they crack these ears right here. You may, if you have a crack here, or if one of the ears actually falls off, you may need to take this in and to somebody who does aluminum welding. Fortunately, this is this particular aluminum alloy can be easily welded. Now, I'm going to, with this bolt gone, I'm also going to loosen and remove this screw. This is a keeper. It keeps the idler shaft and the bushing around it from walking out. There may be another screw, depending on the age of your machine. There may be another screw here to remove. And on this particular machine, there is also an Allen screw that is between the bushing and or keeps the idler shaft in the bushing. Now this bushing has a slot right here, and if I insert a screwdriver in that slot and turn the bushing, I take the tension off that Poly V or Gilmer belt. Now, in some cases, if you have a machine that hasn't been worked on for a long time, you'll find that this thing won't move. In fact, it wouldn't move on the Goldie when we first took that apart. You'll have to very carefully spread these ears apart like this, prying with one screwdriver while you turn this with another, in order to get that to move very gently. You know, once again you can damage these ears by prying them apart as well as you can by squeezing them together. All right, tension's off the belt. Now there is this bushing that goes around the idler shaft is actually a eccentric bushing, and it's held in place, or the bushing and the idler shaft are held together by an Allen screw that is under here. Not all Shopsmiths have this, but this one does. Okay, so I loosen that Allen screw, and now the bushing, I can work this back and forth, and the bushing should come out, and it does. There we go. Bushing out, the idler shaft is flopping around. Now what we're going to do is we're going to simply, I would be reaching through the hole here, but I would work that idler shaft out and the belt out along it, and then I'm just going to drop the idler shaft down and let it sit there. Now, depending on the repair you have to do, you know, you might want to reach in here with one hand and spin this bearing and make sure that it's moving pretty well. You also may want to play with this and make sure that is working. The sheaves are going back and forth. And finally, you want to check this bearing right here on the back and make sure that is in good shape. So, but you can leave the idler shaft in. If you have to take it out, you'll have to drop the motor pan off and get it out that way. Although I have on occasion worked these things out and around, but you really don't want to see me do that because I usually lose my religion in the middle of it. Okay, next step is to take the Poly V belt out, and to do that we have to remove the drive shaft right here. The drive shaft is held in by a retaining ring, and this retaining ring rides in a groove right here around the inside of the casting. And if you look at that retaining ring, you'll find a little tab. And we're actually going to need 2 screwdrivers for this operation. One to pry up that little tab, I'm not quite getting a hold of it. This is a slightly smaller screwdriver blade. Let's see if I can get it. There we go. I am. There. I'm going to get it that way. Now I'm prying it up and out, and I'll get this other screwdriver behind it. There we go. Now I've got it. Once I get that pried up and out and get the screwdriver behind it, I can pull it out just like a spring. There we go. That's it. That's the retaining ring right there. Let me put this over here. Okay, now I'm going to lift up on the Poly V belt while I pull this out. Now, in some cases, this will be stuck. In fact, in most cases. The only reason that this comes out so easily is in the last 2 weeks I've done this about 27 times practicing. So what you may need to do is loosen the Allen screw on the top of your Mark V casting, or the headstock casting. This is the Allen screw that it serves as a guide for the quill. Loosen that, and then extend the quill until you'll extend it well past what you usually do until the splined shaft right here comes out of the drive sleeve. Then we put a piece of wood, just a thin piece of wood, between the spline shaft and the drive sheath, and you can actually then, you gotta get this engaged. There we go. There's just enough. You can push that out with this. There we go. Also, a little bit of wiggling helps. Holding your mouth just right and knowing the proper swear words. This is the drive shaft. You want to make sure that those bearings run nice and smooth. And to remove the Gilmer or the Poly V-belt, all you do is extend the quill and pull it out like this, and you're done. And that's it. We've now completely disassembled the drive sleeve, and I'll show you how to put it back together in a minute. Well, actually, we haven't completely done it because there's one more piece I want to show you how to take off. This nylon drive sleeve, which fits the splined shaft, occasionally the splines inside this nylon drive sleeve become stripped, and this thing needs to be replaced. The older ones were made out of a type of nylon that got brittle, and sometimes they just break right out. In order to replace that, all you do, there's a little ring that acts as a spring, and all you do is pry up on this, and you'll feel that spring click. There it goes. It clicked, and then this pulls right off the shaft. This is splined too, and there's a groove around here in which this ring fits in. And to put the new one back in, all you do is push it in place until you hear that click. Okay, now let's put this puppy back together. Let's put first of all, we're going to put the belt in, the Poly V belt, or Gilmer belt, depending. All right. Now we're going to hold that up while we insert the drive shaft and sleeve. We'll put the ring gear, or the retaining ring, back in its groove. Fortunately, this isn't nearly as hard as it was to get it out. You just have to get it started, and then you just sort of compress it around in there, and then press it in place with a blade screwdriver. You can see it click into, there it is, it just clicked into that groove. Okay, that's in place. Now, we need to get this Poly V belt properly placed on these grooves. You want to have it, okay, as you look at this Poly V belt, I'm placing it one groove to the right and 3 grooves from this boss on this casting. That is the proper place for this, so that it hangs correctly and is centered in the on the idler shaft. If it's any place else, it will hang sideways, and it'll wear unevenly and may actually put stress on the bearing. So there we go. I've put the idler shaft through. The Poly V belt is centered on the idler shaft but it's over 3 grooves to the left on the drive shaft. Now let's put the eccentric bushing back in. We'll put it in so that the thin area is up at the top. That keeps the and if you put it in and you can't see that groove, you know you've done it backwards. Also, if you can't get it back out, you know you've done something wrong. There we go. Okay. You want to be able to see the groove that you used to loosen it, because we'll need that same groove in order to tighten it. Now let me get that back in there. There we go. All right. I'm going to tighten the Allen screw at the bottom of this that holds the bushing to the idler shaft. Now, I don't want to over tighten this screw. In fact, there's a lot of over tightening in this thing that I don't want to do. If I tighten that screw down too much in the bushing, it's going to put pressure on the bearing, and the bearing is going to wear prematurely. In fact, it may not even work. All I'm doing is snugging that up. That will hold it just fine. And I'm going to put this keeper screw back in place so that stays where I need it to, and then take this screwdriver. Now, to tension the V belt, the poly V belt, all you do is turn this until you feel it stop. Now, at this point, the V belt should be properly tensioned. You don't keep on turning and turning and turning. It just, you can stretch out that V-belt, but you want to take the slop out of the system, but you want to be able to press on the poly V-belt like I'm doing right now, and maybe get it to depress maybe 1/8 of an inch at the most. But it should be fairly tight. The other thing is your casting may be a lot looser than the one I've got here. This, I'm very fortunate. I can turn this bushing in it, and there's enough friction that it stays where it is. You may have to turn this and then quickly tighten the bolt down here in order to preserve that tension. I don't have to do that with this one. Let's put the bolt back in, by the way. Bolt, lock washer, square nut, and then the 1/4 inch Allen wrench, and we tighten this up. Now remember, I don't want to over tighten this because I could crack that ear off. I just tighten it a little bit. There we go. It's nice and snug now, but it's not very tight, and I still have plenty of tension on the V-belt. If I turn everything is riding very smoothly. Good. Okay. Let's put the drive belt back in place. I'll work this up, and let me turn it sideways so you can see what's happening here. I'm working this up and over the idler shaft. Then I push or pull I'm going to get this from around the motor shaft. I push or pull until this drops into place in right here in between the control pulley and the idler pulley. Now, remember that little loop we took off the quadrant or the pork chop? I'm going to put that back on now. There we go. That's clipped in place. If you want to see this move, this is the one time you can move this without damaging your Mark V. I'm going to turn the speed dial. See how that goes back and forth? There you go. That's what happens when you turn the speed dial. Okay, I'm going to take it all the way out now. And then I'm going to walk the belt back on to the fan sheave and the floating sheave. Now, it's fairly hard to do just like this. The spring puts a lot of pressure. So what I like to do is take the sheaves between both hands, I'm putting the palm of my hand against the end of the motor shaft and pulling the sheave, and then getting the drive belt in there to kind of hold those sheaves apart, and then it walks on a whole lot easier. Now I'm going to sit here and I'm going to spin this until that belt has a little tension on it. There we go. Now let me. This piece of paper, by the way, is resin impregnated, and this is the insulator for the switch. There we go. All right. We now have the correct tension on both belts. Everything is back together. Let's plug it in and see how it works. You want to run it a little bit anyway, and take it through the whole entire speed range in order to get the belt seated and make sure the drive belt is under the proper tension. Now remember this, you can go from slow to fast very quickly, but when you go from fast to slow, you want to do it. You don't want to go too quickly. Otherwise, you'll get ahead of the machine's ability to adjust the belt tension, and you might do some damage. Looks good and it's sounding good. Now, one last thing that I'm going to show you, and that's how to do. By the way, this is the official service repair manual, and little by little we're going to work through a way. But this is the whole Shopsmith system. By the way, it isn't. You don't need this all for the Mark V, but we're going to work our way through the entire part of the service manual that pertains to the Mark V as we restore this Golding. Let me unplug this again. I've left it at high speed. Notice, occasionally you have repairs that call for a high speed adjustment, and this is important. This is you're aligning your speed dial with the indicator that's up here at the top. You'll notice I left it on fast, but I'm a little past fast here. I'm going to do this high-speed adjustment and all it is taking the speed dial off, taking the control handle of the speed dial off, setting the stop at the back, and then adjusting the position of this dial. Remember I showed you that little pork chop and how it moves the control sheave back and forth and back and forth. If that pork chop swings too much in this direction, it will contact the control sheave right here. The control sheave will actually hit. If I take this, I don't know if we can get in here close enough, but but there are some parts of the speed changer that stick out. Yeah. Okay, there we go. Hang on. There you go. There. Right there. Okay, right under that piece of paper, that little thing that you see sticking up is the pivot for the quadrant. And the control sheave can come over and hit that pivot. You want to be able, you want it to stop before it does that. And there is an Allen screw, a long Allen screw back there that acts as a stop for the quadrant, and that's part of this high-speed adjustment. So let's first of all, let's take the control handle off. We need a 3/32 inch Allen wrench. There we go. Now comes the hard part. We have to find. Oh, I never do that. I found it. I am so happy. There's a little teeny tiny Allen screw in here that it normally. We've been doing this all week. It normally takes me half an hour to find this sucker. Okay, right there is the Allen screw. This is the inside of the speed control handle. The teeth are all in good shape, as you can see, and the Allen screw is right where it should be. Okay, here's our speed control mechanism here. It's set at high speed now. It's not making a noise, so the speed is correct. Now, actually, what we would do if I had a tachometer, we would set this at 5,200. I borrowed a tachometer from back in the shop and set this earlier, and I know that right now it's pretty close to 5,200 RPM. If you don't have a tachometer, you can take a look right here at the fan sheave and the floating sheave on the motor. If the belt is somewhere between 1/16 of an inch and 1/8 of an inch down from the ridge or the rim of that sheave, then you're pretty darn close to 5,200 RPM. That's where it should be. This belt, by the way, should be a half an inch thick, maybe a little less, maybe a little more, depending on how it was cut. But if it gets down below 7/16, it will dip way down there, almost a quarter of an inch, and at that time, it's worn enough that you need to replace it. If the belt is fatter, sometimes they come to you when you buy the new ones. If it's fatter than half an inch, you may want to set this at 4,800 to begin with, and it will wear in as the belt goes down to just a little bit below half an inch thick. Let's come back to this. Remember that Allen screw I told you about that uses it's a stop for the pork chop. That's right here, and I'm going to take this wrench and I'm going to loosen the jam nut that holds that in place, and I believe I need the 1/8. Yes. Now I'm going to turn that until it is tight. I want it tight against that pork chop. All right, and once I've got it there, I'm going to hold it there and tighten the jam nut. There we go. Now, that means that the pork chop can't pull the control sheave any farther towards that pivot boss on the speed changer casting. Now I want to set this to fast and put it all back together. I've got to get that Allen screw in this little detent here in the top of the speed changer shaft. By the way, if you have a hard time taking the handle off or putting it back on, it can be because this Allen screw wasn't properly set and you've got a lot of burrs and galls around that depression. Just take a little needle file and file them away. Won't hurt the shaft one bit. Okay, there it is, and there it is seated against in a proper place. It's on the fast indicator. And I'm wiggling this back and forth to make sure I get in that detent. Tighten it down, and done. Now, let me plug back in, and let's see how we are. There you go. It stops it slow. so I guess I did it right. You'll find if you do have a tachometer, you'll find that if you go to our speed chart, we have all these letters around here, and you guys are very fond about complaining about those letters. Why don't we put the numbers on? There is enough going on in this system that it is impossible to put the numbers on. The actual speed of the drive shaft depends on a lot of variables, especially the wear and tear on the drive belt. And so you may be 50, 75, even 100 RPM off of what some of these letters may indicate if you go to the speed chart. That won't affect the quality of your woodworking, though, one iota. That's it, guys. That's the drivetrain in a nutshell. I'm going to go straight from here over and push this back, and I'm going to jump into bandsaw lumbering. If you have questions about what I just showed you, I'll ask Drew in a minute if we have any now. But if you want to put them in, because see, I'm speaking to you right now this minute, and depending on where you are in the United States, this could be coming to you a minute, 2 minutes, 3 minutes later. So put the questions in, and I'll take them after I do the lumbering.